So next up, we've got Shawn, who is the lead of developer experience, and he's going to talk about how to become a parachain. Oops.
No.
Okay, so then we're going to...
Full screen.
Does this work?
Okay. Yeah. This. Cool.
Oh, actually, it's not this mic, but this mic.
Sure. Hello, everyone.
Oh, come on in a second.
Testing? Okay, cool. Hey. Hello, everyone. Hope you've been having a good time at Sub 0.1. Yeah, in general, this is a Substrate conference. You've heard a lot of people building on Substrate, but I think the thing kind of maybe less spoken is the fact that a lot of people are interested in building on Substrate because of Polka Dot, this kind of larger network. And so I wanted to talk about how exactly the mechanics and kind of what you need to do to actually join this network. If you're building awesome Substrate chains, definitely we want you to join. This kind of tells you how. But first, let's talk about what is Polka Dot. So Polka Dot is a network that connects blockchains, ultimately a vision towards a multi-chain future. Polka Dot attempts to solve 3 problems. First being interoperability, the ability for blockchains to talk to one another, scalability, the ability for these blockchain distributed systems to do more, and shared security, basically trying to avoid different blockchains from competing over scarce resources, things like users or computation or stuff like that. But I think it's also important to try to argue why we think there's a multi-chain future ahead of us. Well, I think first we definitely know that the blockchains will be in our future, and it's because blockchains ultimately solve trust problems. They're open, they're decentralized, they enable people to interact in a way where they can have less trust and more truth, right? And then specialization, I think we can help solve scalability issues. Really, when we're talking about specialization, a blockchain that tries to do everything doesn't quite do anything the best. And as a result of trying to do everything, it's just not as performant. If you can specialize the blockchain, configure it to be doing its one task the best it can, you can actually gain performance and as a result gain scalability. And then if you have all these specialized blockchains, ultimately interoperability is what adds the real world value. These individual blockchains, these individual pieces of logic doesn't really add value to the overall network. But when you can have them talk to each other, communicate, and actually use each other, that's where the real world value comes from. And so this is kind of a picture maybe you've seen before about Polka Dot. You can see in this middle we have the relay chain. This is itself a blockchain, and all around it are all these parachains. There's a lot of mechanics and stuff around this, but the truth is there are a lot of people in this room who want to be this square right here, one of these parachains. And I'm trying to explain, what does that even mean, right? And I'll try to oversimplify it to try to get across the message of why you might actually want to be a parachain and why building on Substrate may enable you to do that. So what does it mean? So as a parachain, first you get the opportunity to put your blockchain's latest blockhead onto the relay chain. Easy enough. Next, as a parachain, the blocks you submit are verified by validators using a WASM runtime you're able to store on the relay chain. So if you're familiar with Substrate, you know that your runtime is composed of WASM. This WASM is stored on the relay chain, and it gets verified by validators. Finally, you get the ability to communicate with other parachains using an abstract message passing system. Great, but what do these things actually mean? What are the underlying messages here? Well, because you can place your blockchain's head onto the relay chain, you can actually achieve deterministic finalization for your chain. This means that you can offload consensus, the hard part of trying to reach finalization, to this shared network. Because the validators have the WASM runtime for all the parachains, you actually share the security of the validator pool with everyone on the relay chain. Anyone in this large validator pool can help validate your blockchain. Finally, because message passing is tracked on the relay chain, you can actually prove the delivery of messages, and this really facilitates trustless interactions. And this is such an important part, which is so hard to achieve on these distributed blockchain systems. Great. That sounds awesome, right? So everyone should become a parachain. Well, unfortunately, there's some scarce resources here. Polka Dot has n-squared complexity. So as we add more parachains, it becomes increasingly harder to add a next one. Things like networking, message passing, block size, they can all limit what a single relay chain can do. We have ideas. I mean, this is way above what my pay grade, but ideas of these nested relay chains where you have the actual Polkadot relay chain, and again, it is just a blockchain. So connected to it could be another relay chain, and you can have these kind of ecosystems, right? Like a gaming relay chain where all these other parachains to this relay chain are gaming, and then you have a DeFi relay chain. This all finally connects to the main Polkadot relay chain. But this is kind of, a little bit ahead of what we're able to accomplish today. But this is kind of a bright future of how we might even solve the scalability issue that a single relay chain can only achieve so much. Let's talk about relay chain volume. So optimistically, the Polkadot relay chain may support up to around 100 parachains. That's kind of what we're hoping for. And across these different slots, we're going to have different kinds of para objects, basically, things that are putting things on the relay chain. So first we have some system level permanent chains. These are things like the nested relay chains, but we also have other system level things. I think an example is we have ideas or thoughts to move the balances feature of the relay chain off to its own parachain. So the relay chain maybe only manages the actual parachains, message passing, that kind of stuff, but the actual balances is managed on a parachain that's connected to it. So that would be like a system level chain, right? Then you have these leased slots. These are basically the normal parachain. So if you win an auction, you get a slot on the relay chain. You become one of these permanent slots, or not permanent, but you get a slot basically for a lease during this time. And then finally, this new thing, maybe you heard of it, maybe you haven't, these parathreads. And basically, we think that any of these extra capacity that the relay chain could support, we can actually have this parathread system where people who want to use Polkadot, but don't necessarily want to commit the huge cost to get a leased slot, maybe who want to just try it out, or maybe even people who had a leased slot but no longer have one can continue to use Polkadot through this parathread system. So let's go a little bit into parathreads and parachains. The thing you should know about them is that ultimately they have the same developer API. So from the perspective of Polkadot in terms of developer API and perspective of you as a developer building on Polkadot, you don't have to do anything different if you want to be a parachain or a parathread. In fact, you can freely swap between the two. And this is one of the features that we have, and I'll talk about that more later. But what is different about them? Well, there's a different acquisition process. Exactly how you become a parathread or a parachain is slightly different. I'll talk about that too. There's different scheduling and throughput. This is the main one, where basically parachains offer you full throughput. You get like the premium priority on the relay chain, where parathreads are kind of more pay as you go. It's what's available and what you pay for. And finally, the economics are a little bit different. You as a dot holder who's paying to be a parachain or being a parathread, exactly what you're doing with your dots is a little bit different. And we'll also go into that later in my slides. Okay, so let's talk about the how. So how do you become a para thing, right? Well, the first thing to realize is that Polkadot is just a substrate chain. So I'm gonna, again, this is a substrate developer conference. I'm gonna talk to you about Polkadot in terms of the modules that enable parachains to exist. First we have the Registrar Module. This basically manages all the registration across all the para objects. So active, inactive, parathread, parachain, all that kind of stuff. That's what's happening in the Registrar Module. It also actually supports the parathread auctions. So in here, it tracks the active parachains, and if you want to be a parathread and you want to get a slot on the relay chain, you basically do an auction into this module to get that active slot for that few blocks. And we'll go more into that a little bit later. Then there's a parachains module itself. This is the actual execution validation logic for parachains. It supports message passing, it stores the latest para head and the runtime code, right? Then we have a slots module. The slots module is actually what handles these more complicated parachain auctions. It manages parachain slots and even holds the deposit. When you win a slot, it will hold your deposit into this module. And finally, we actually have a crowdfunding module. And this is a really cool thing I'm not sure many people are familiar with. The crowdfund module allows the community to fund your parachain auction. So you as a person may not have like all the money for your great idea, but you have the great idea and you have the developer expertise. You can actually use the community to fund and back your parachain auctions. And ultimately, this crowdfund module helps you do that by collecting the funds, putting you into the auction, and track community contributions. Okay, so we're gonna go kind of deeper into all of these things. First, let's talk about para auctions. So the parachain auction mechanism. So the parachain auction mechanism uses a candle auction. A candle auction is this auction where basically, I think back in the day, they would light a candle and they would do some bidding. And basically, whenever the candle went out, this is kind of a random time, the auction would close and whoever was the last bid would win. And for the same reason, and yeah, and I'll talk a little bit more about that, but that's kind of the idea here that we don't quite know when the end happens. This kind of auction is initiated by governance, so maybe a democracy proposal, maybe, I don't know if there probably won't be ever pseudo, but you could basically say, hey, there's more room for more parachains, governance can go through and initiate a new auction. The auctions happen one at a time, and they auction off a 2-year slot. These slots are split into 4 parts, which are 6-month leases. What's cool is if you win this auction, you put your money into a deposit, but then you get all of the dots back to you at the end of the lease. Let's talk about the candle auction system. So the candle auction system kind of has 2 periods. There's an opening period and an ending period. The opening period is basically time to allow people to realize there's an auction, to make the initial bids, to kind of figure out what the right general price might be for a parachain slot. But then you reach this ending period. And this ending period is known, it's fixed, and anytime during this ending period, it could randomly close. But the way we do this is we actually let the entire ending period go through. So during this ending periods, everyone's bidding, everyone's going up higher and higher or changing whatever kinds of bids they have. And then once the ending period is over, we then retroactively decide what the ending block is. So whatever the winner is of that block, that's the winner. And this ultimately encourages healthy price discovery and discourages sniping. I don't know if you all use eBay, right? There's some person, 1 second, who jumps the bid up a bunch. This avoids that. You don't know when it's gonna end until after it's ended. So you're here trying to make bids which are truly what you think the value of this slot is. This also helps mitigate the effects of malicious block producers. So as a block producer, you ultimately have the ability to maybe ignore a transaction or not produce a block or do any of those kind of things. If a block producer doesn't know when it's going to end, they don't really have the incentive mechanisms there. They just want to collect their fees, right? So it kind of helps that. Another thing is that this kind of mechanism doesn't require a commit reveal scheme. So I think there's another auction called like a victory auction, where basically you can like, have some kind of, say I have some bids, it's encrypted or hidden, and at the very end, everyone reveals their bid and that kind of stuff. That's kind of a 2-message process. Here is just a 1-message process. You can make an initial bid and you can win, not having to do anything else. So let's talk about the mechanics of the parachain auction. So you can see here you have Alice, Bob, Charlie, David, Emily, and they all are bidding on a same slot. And again, the slots are broken into these 4 lease periods, all 6 months. You'll see that a person will say what lease periods they're interested in and the bid, the amount of dots they're willing to deposit for those lease periods. Now, what might be confusing at first is that this isn't like a normal kind of bid that be broken up like this. Like you see Alice here has bid 200 for 4 slots. Alice isn't saying, oh, I'm willing to pay 50 dots per slot. Actually, Alice is trying to say, I'm willing to lock 800 dots worth of value. That for each of these quarters, she's willing to keep 200 dots locked away, right? So you can see here, if you have 4 slots and you bid 200, you actually have a locked value of 800. Whereas if you only try to pick 1 slot or a quarter, and you only say locked in 200, you see the locked value is only 200. Of course, we try to maximize the auction mechanism, tries to find the right pairing of people. So like Bob and Charlie would be paired together, Dave and Emily would be paired together, Alice would be on her own, and try to figure out ultimately what is the largest total among this. So even though someone like Dave has the largest bid, when paired with Emily, who has a relatively small bid, the overall total value, locked value here, is less than what Alice would have done. So Alice would actually be the winner in this parachain auction. Does that make sense? Mostly? Okay, nodding heads, good. Okay, let's talk about allowed bids. So we actually have some limitations on what kind of bids you can have. So first, you can have multiple bids for the same slot. So you're able to say, make a bid, say, I want all 4 quarters, I want all 3 quarters, I want 2 quarters, that kind of thing, and I have different amount of bids, bid price on each of these things. So maybe like, if you're able to obtain all 4 quarters, you're willing to deposit a lot more. But if you only have 2 quarters, that's fine, but you're not willing to pay as much for that, right? But there are some things. First, ranges must overlap. I.e., you cannot have bid 3 and bid 4. You see that bid 3 and bid 4 would basically give Alice the full 4 quarters, and that would conflict with bid number 1, which is asking for the same thing. Also, you can't. You must have continuous lease periods. Basically, we don't want people to have like Q1, then not Q2, and then Q3, Q4. Because this is like an onboarding process, offboarding process, onboarding process. It's not really a natural flow for being a parachain. Cool. And so again, this auction system is great, but to be honest, it's probably going to cost quite a bit of dots to be able to get into this wins auction. So if you don't have the funds yourself, you can crowdfund your parachain. You can actually allow the community to give back to your parachain and allow you to win these auctions. The incentive mechanism here is basically to reward those users with your native token. And then the Crowdfund module automatically handles the rest of the auction process for you. So let's take a look at the mechanics of that. So if you want to start a crowdfund, first you must make an initial deposit. Basically, we're trying to, I guess, prevent Sybil attacks and try to make you pay up front for the kind of costs that it costs on the relay chain for doing a crowdfund. And once you make the initial deposit, anyone can contribute. But you must at least contribute a minimum contribution. So there's a minimum contribution limit for that. Basically is the cost of us tracking someone's contribution to your crowdfund. Every time a new contribution happens during an ending period, it triggers a new bid. So it's automatically bidding for you, basically. And then when you make a crowdfund, you set an end date, a specific end date. And this end date can actually span multiple auctions. So you can have an end date which goes, when they say, over 2 auctions. And if you don't win the first one, maybe your crowdfund will win the next one. You'll see there's the initial deposit, the amount raised, and there's also a cap. So you cannot raise more than the cap. So I know some things like GoFundMe or some of the other crowdfunding services allow you to go way over the limit. We actually limit that if you say very firmly at the beginning how long the crowdfund is for, how much I want to raise, and that really gives a good idea for people who are backing you what is going to happen, what they expect to happen when they support your crowdfund. And the mechanics run, so ultimately the module generates a child tree. If you want to learn more about child trees, I have a talk tomorrow as well about storage. But we have a child tree which tracks user contributions. If you know anything about Merkle trees, basically you can use the hash of this Merkle tree to verify any of the contributions in the tree. So someone can say this tree off-chain, and we can use this, tree head to basically verify, yep, these are all the bids, these are real people who've contributed. Your crowdfund can be a success, as in you win one of these auctions, or a failure, as in you reach your end date and you never won one of these auctions. But in either situation, you'll eventually retire, right? And when you retire, basically, people can recollect their funds. It's nice. And finally, if you're not able to do a crowdfund, if you're not able to get enough initial deposit to win an auction yourself, the final option we have for you is a pair thread auction. The pair thread system in general is much easier to enter. It uses an English auction. This is the very standard auction where everyone's raising their hand saying, I bid higher, until someone wins. Pair threads need to lock a nominal deposit which can be refunded. So again, in order to become a pair thread, you really, as a much, much lower amount of dots you really need. The auction itself happens every block. And the number of winners in a pair thread auction is determined on your thread count. So how much availability there is on the relay chain itself, we can have a fluctuating thread count, and basically however much we can support, we will support winners to join and participate in the network. And in this situation, whereas in the Parachain auction, dots are returned to you, you're actually paying fees here. So the dots used in the bidding system for the pair thread auction are actually consumed. So the way that it's currently programmed in Polkadot is that 20% of this contribution goes to the block producer. So whoever produces the block that you want an auction in gets a nice little bonus. And then the other 80% goes back to the treasury, which is, of course, we know funds, more community things, and basically as a way for Polkadot to give back to people who want to build on it. So the mechanics of a pair thread auction. So we actually take advantage of fees and tips. So if you're familiar with the Ethereum world, you might know you can increase the gas cost to increase the priority of your transaction. So if you want to make sure your transaction gets on the next block, you can do some crazy high fee and you can get in there. And we actually have a similar system in Substrate where you can leave a tip. And these tips basically incentivize the block producers to put you higher in the transaction pool. They want to basically mine your transaction so they can get your fees. In this case, you have Alice, Bob, Charlie, Dave, and Emily again. They're all making this call to select pair thread. This is basically making a call to a bid. But you can see that Alice, Charlie, and Emily have all made a tip to say, hey, you should consider my transaction a little bit more than the others. And as a result, in the transaction pool of Polkadot, Alice, Charlie, and Emily are higher than Bob and Dave. In our virtual situation, we have a 3 pair thread cutoff. So basically, we just have some logic that says, hey, the first 3 people in this transaction pool who made this call are the winners. It's that easy. So you can see here, this kind of auction happens every block. And there's a natural economy that's happening around the fees, right? Like in situations where there's lots of traffic for a pair thread slot, the fees just go up. When there's not a lot of traffic, fees go down. It's possible you could win a slot without paying any extra fees at all, right? And this is kind of a really cool natural system. In order to do this, we have this signed extension logic. I think I'll go a little bit into it. It's actually a cool feature I don't think anyone else is going to be talking about at Substrate, and it's quite a little bit technical. So winning a pair thread auction. So if you win the slot, great. You'll be queued to submit a new head on the next block. So you can make a bid on one block. The next block, you'll figure out if you won or not. And then you actually get 4 slots to submit your new head. So if you miss your slot, you get 3 additional retries. It all works. So here, you can basically just have some window of opportunity to put your new head onto the relay chain. So this kind of window here is basically allowing for any type of network propagation, time for you to collect the block, that kind of stuff, right? It just gives you a little bit of leeway. Does this make sense? Good? Nodding heads? Okay, great. Okay, so then let's do an aside. So I don't think this is talked about any time else at Sub-Zero, and of course this is a developer conference, so let's talk about some of the developer tools. Something that's new in Substrate, which didn't exist in the last Sub-Zero, is this thing called signed extensions. We actually use this for this pair thread auction system, and it's quite clever. This is the function for a pair thread auction. You can see, besides the function header here, there's no logic. If we read the comment code, this is everything else checked for in the transaction signed extension. So how can we use this no code to do a cool pair thread auction? Well, basically, we take advantage of this new signed extension feature. The feature in general is a way for transactions to be extended. In one literal way, you can add extra data to your normal extrinsic format for your blockchain. So if there's something about your blockchain where like, I always need this extra piece of data in there, you can do that. But in addition, there's this validation function which allows for transaction queue to quickly eliminate transactions based off some logic that you decide. So if we take a look at this, you can verify implied information about the signature. This is an example of a checking replay attack, so we use it for checking replay attacks. So if you're building different substrate chains, you might know that the transactions might actually work on other substrate chains if we didn't check that the transaction has encoded into it the information about the genesis block. But it doesn't literally include the genesis block into every transaction. That's like a huge waste of space. What it actually does is, there's some implied information where we actually, when you generate the signature for your transaction, you take the transaction, you take this genesis block, you form the signature with that information in it, and then you take out the genesis block information and just pass the transaction itself. We know on our own substrate chain what the genesis block hash is, so we can add it back and then do the signature verification in that way. So you can actually kind of sneak in some data, or you can actually have literal data there and have that be verified. But you can see this is kind of a cool feature. You can also decrease priority in the transaction queue. So this is the whole fee system, right? So if we have implemented fees using the signed extension, if you add a fee, we will make sure it gets to the right block producer, and we will basically increase the priority of your transaction queue. You can also decrease the priority. If for some reason you can detect some data in there is really crap, you can decrease the priority of a transaction before it even gets to your network, right? And finally, you can trigger additional logic for certain functions calls within your runtime. So the signed extension knows about the functions that you're calling, and you can add your own additional logic wrapped around it. So this is actually how we limited chain functionality in Kusama. So in Kusama, you might know, I think we just heard that we just enabled transfers. And even before that, we disabled governance, we disabled all these things, just to make sure it works. We actually use signed extensions to say, hey, is the call coming in calling balances module? If so, sorry, no. And then when we want to enable it, we just remove that one check, and basically now we can enable these calls to the balances module and stuff like that. So you really have now this plug to access these transactions, do verification, do priority handling, all before it even hits the runtime execution logic. Cool. Cool. Okay, para economics. So parachain economics. Locking your dots isn't free. That is the economics. That there is an opportunity cost to taking this thing which is worth value and blocking it away from your ability to use it. So ideally, you are trying to lock your dots away because you think by joining the network and participating that you'll increase the value of the dots. And ultimately, this is a good return of investment on the dots that you locked away. Pretty much makes sense, right? Pretty simple. Parathread economics, a little bit different, but it's the same kind of thing. Ultimately, what you're trying to do with parathreads is incentivize collators to pay this bid, to make this bid, pay this fee on your behalf. And the way you do that is basically you incentivize them with your own native token. So native token payout can be the transaction fees collected in that block, that totally makes sense, but can also be some additional logic that you add to your parathread with like some parathread token sponsorship, where basically, you can see here the graph, this is the value in dollars, this is the number of relay chain blocks since last finalized parathread head, and the longer and longer your blockchain hasn't finalized, or hasn't put a block on the relay chain, the more this function will want to pay the user who does it. And eventually we reach a point where you will get paid more in your native token than it would cost you to pay the fee on the relay chain. And this is good for you. You're getting paid to do this. And this kind of natural economy will basically allow blocks to naturally be produced when the parathread bid is less than the native token payout. So this is nice, and this is kind of how it works. And of course, this the cost of winning a parathread bid is going to go up and down based on the usage, right? Based on the availability of parathread slots on the relay chain. Make sense? Nodding heads, good. Okay, so pair life cycle. And so what's really cool, and I think a feature that's not really well represented until now, right now, about pair threads is that it actually completes the life cycle of what it means to be a parachain. It's kind of a little bit awkward before when you have parachains, and at some point maybe you didn't win a slot, and now you're just kind of going to nothingness, right? Like you just can't produce blocks. All of your consensus is basically kind of like for naught, right? And with pair threads, we actually give a really great offboarding story. If for any reason you don't win your slot, or even if you want to sell your slot, you can become from a parachain to a pair thread. You get the same full security, the same instant connectivity, but you just have less kind of volume throughput, right? Or if you're a pair thread and you say, hey, I want to just try out the network, see if it's actually hyped up as much as it's supposed to be. You can try a pair thread, start working, and be like, wow, this is a really awesome network. I'm doing really awesome things. I want to increase to become a parachain, get that full throughput. So you can upgrade and become a parachain. And what's happening here is actually the ability to swap freely between parachains and pair threads will actually create almost secondary markets for parachains. That there will be people who say, it's not well understood necessarily what the value of a parachain is today. And it may change drastically over the 6 months, 1 year that we initially launched Polka Dot. So this kind of swapping mechanism can allow pair threads and pair chains to kind of have this economy to kind of buy and sell the slots based off of what the interpreted value is. And as a result, you actually get a really good idea of what being a parachain is worth. And this really kind of helps just the overall economy. You don't want to go all over the place with the prices. Here, with this kind of natural marketplace, you can actually derive very quickly what a natural price for being a parachain is. Cool. And of course, earlier today, hopefully you listened to Rob's talk and maybe you participated in the workshop about Cumulus. So, ultimately you are building substrate chains today and you want to maybe get on this network, follow these kinds of different processes I talked about. Well, we have this library Cumulus, which makes you easily convert your substrate code base into a compatible Polka Dot parachain. It's broken into a few components. I won't even go into it. You heard about it earlier today, but this is really the starting off point. And the main goal here is that, along with the knowledge you have of how to become a parachain, you need to ultimately write a chain and then make it join the network. And with Cumulus, we're trying to make that as easy as possible. All the work you've done is for something, and if you want to come here, we make it as simple as possible for you to do that. And yeah, that's the end of my talk, and I'm very happy to answer any questions.
Hi, I'm Julio. How much do you estimate is going to be like a minimum amount for the crowdfund? Is it?
Yeah, so that's a good question. I can work a little bit backwards from that. So to win a crowdfund, you need to win the parachain auction. To win the parachain auction, there's some math you can do. I think there's like 10 million dots. We expect that 50% of the dots will be locked away. So if you do the math, there's like average price per slot of like 50,000. I don't know. I kind of hesitate to say any numbers, but ultimately for a crowdfund, you will need to basically be on the order of that average dots to win an auction. Does that make sense?
Yeah, okay.
Yeah. So there will be some price. You'll be able to see in an auction how much slots are going for, and basically set your crowdfund to that price. I would agree. I think what you're saying is maybe for the very first crowdfund, it's a little bit hard to know, but I don't really have a way to say that it's going to be this price. But I can tell you, 10 million dots, 50% locked. You can do some math.
And 100% of those dots are recovered like back to the users or to the parachain.
You're talking about for a crowdfund, right?
Yeah, afterwards.
Yeah, so the crowdfund, all the 100% of the dots do go back to the control of the parachain. Mm-hmm. I think there are some underlying mechanics where a malicious parachain would be able to move the dots to another location. So actually you can make a call as a parachain to basically say, I change the address where the return dots go to. I think things like governance can handle these kind of malicious parachains, help recover the funds from a user. But at the end of the day, if you don't do anything and you do the natural process, yes, funds will go back into the account, and naturally the module which handles the crowdfunding will allow users to recover their funds from that automatically.
Okay. What about transaction cost then? Like when the 100% of the dots are recovered, what the transaction cost of all that operations that were made on chain?
Yeah, I think there's a nominal. You basically make one call, and I'm sure there's a fee for that. But we actually do some logic in the code itself to reduce the fees of transfer. So we don't, for example, we don't charge you a transfer fee. I think we do obviously charge just a normal call fee. It's going to be the cost of a transaction. Like it's going to be like one small cost to make one call to recover my funds. Yeah, it's going to be minimal.
All right, thanks.
Questions? Cool, we have a question there.
Well, kind of an obvious question, but when can we hook our first parachain to Kusama?
That is a great question that I don't have the answer for. I think that people at Parity are very, very hard at work. Hopefully, if you went to the Cumulus workshop or talk, you'll see that it's still kind of something that's very much in progress. But we're on the cusp of that, really, if you look at it, right? We have Kusama, we have a chain that's working, there's governance happening. The next step is kind of that thing, and I think that's what we're working for as hard right now. I can't give you a date, though. And I think one of the things, the trends around Substrate in general is it's ready when it's ready. And I think that's actually a pretty good attitude. It would not be good is trying to release something that's broken, that causes a bunch of panic, that causes these things. We have ideal milestones and kind of things we're gonna strive for, but really it's ready when it's ready. And I think that's the best thing for the community.
Hi, Albert, my name. How much can you put into a block? I mean, how big is the size of a transaction, especially this data field that you mentioned? How much can I put on extra data in there?
So this is a great question, and there's actually a feature specifically around this thing called weights. So this is actually also introduced. I don't know if we have a talk on it during this Sub-Zero, but this is something that's new since the last Sub-Zero. And this weight mechanism basically allows you as again, the runtime developer, as the blockchain developer, to determine exactly what these weights are. So there is an overall weight limit to your blockchain, how much a block can have. You can set that. You can set how much of that weight limit is for normal transactions versus like system level transactions. I think on Polka Dot we have like 70% on normal transactions, and we reserve an extra 30% for anything like extra. And that's not normally accessible by normal users. And then you also have the ability to control on a transaction level what each function would cost to your blockchain. So if you actually go look through the code of Substrate now, there's this like weight, fixed weight kind of thing all over the code base. And this number is adjusted based off of the underlying logic. What doesn't make sense in Substrate and as a runtime developer is to like do the same kind of gas weighting thing that you would do in Ethereum, where every single call is an opcode lookup and all that kind of stuff. It's just not efficient. What you should do, because you control the runtime, because it's not malicious code, because it's something that you control, is basically kind of ahead of time weight all these functions, understand what the cost it is to your blockchain, and make reasonable estimates of the weights to your blockchain. So the answer to your question is you control that, and it's really up to you and what your blockchain does.
Thank you.
Yeah.
Are there any profiling?
Sorry, Mike.
Oh, sorry. Are there any profiling tools that help on that side?
I think that's all in progress stuff. I mean, the weight thing is relatively new. I know internally, one of the things we've been doing is we created some scripts which basically sends thousands of transactions to various functions, trying to see what the cost of increasing the database is, random cost of the function being called over and over is, that kind of stuff. And we have some rough estimates of what the weight is there. But I assume as time comes, these kind of tools we develop internally or externally, and we encourage everyone to, if this is something that you're familiar with, absolutely go ahead and go wild, we could definitely use it. I think that what we do right now is a little bit immature. Cool. Well, thank you for your time.